Hello students, welcome back to Learn 24. In this video, we are going to learn about the integrated rate equations. We have already studied the rate of a chemical reaction and also the factors influencing the rate of a chemical reactions, where we have studied the differential form of those equations. Now we have to study the integrated form of those equations, that is the integrated rate equations, and it is different for the zero order reaction and also for the first order reaction. First, let's learn the integrated rate equation for zero order reactions. Let's assume there is a reactant which will become product and the rate will be equal to minus d concentration of R divided by dt, and that will be equal to K into concentration of R power 0, where K is the rate constant. Whenever there is a power 0 over the concentration, it will give the value 1. So the concentration of R power 0 is equal to 1. So we can rewrite this equation as rate is equal to minus d concentration of R divided by dt is equal to K into 1, that is equal to K. And again we can rewrite this equation as d concentration of R is equal to minus K dt. So this is the differential form. Now we have to get the integrated form. We have to integrate this equation. We have to integrate this equation. Since this minus K is a constant value, we only have to integrate the dt, and the equation will be integral d concentration of R is equal to minus K integration of dt, and integral d concentration of R is equal to concentration of R. So the concentration of R will be equal to minus K, integral dt is equal to T. So it is minus Kt plus C. It is the integration constant. Now we have to determine the value for this constant C. In order to get the value for that, we have to take at T is equal to 0, concentration of R becomes concentration of R naught. This is the initial concentration. At T is equal to 0, concentration of R becomes concentration of R naught, that is the initial concentration. Now replace these terms in this equation. So it will become, instead of this concentration of R, place R naught. So the concentration of R naught is equal to minus K into 0, because T is equal to 0, minus K into 0 plus C. Minus K into 0 is equal to 0, and the value for the C will become R naught. The concentration of R naught is equal to C. Now we know the value for the C. Just replace this C in this equation. So the equation will become concentration of R is equal to minus Kt plus concentration of R naught, and we can rewrite this equation as Kt is equal to R naught minus concentration of R, and we have to know the value for this rate constant, and K will be equal to concentration of R naught minus concentration of R divided by T. This is the integrated rate equation for the zero order chemical reaction. This is the integrated rate equation for zero order chemical reaction. You have to remember this equation. Now plotting a graph by this equation, taking the concentration of R on y-axis and time t on x-axis. There is a slope, it is a negative slope, so draw the straight line downwards. So the K will be equal to minus slope, and the y-intercept is the initial concentration, that is the concentration of R naught. Clear? This will be the integrated rate equation and the graph for zero order chemical reaction. Now let's learn the integrated rate equation for the first order chemical reactions, where the reactants will become product and the rate will be equal to minus the concentration of R divided by dt, and that will be equal to K rate constant into the concentration of R power 1. because we are determining for the first order chemical reaction. The concentration of R power 1 is also equal to the concentration of R, right? Yes. And now we can rewrite this equation as D concentration of R divided by concentration of R will be equal to minus K dt. Now this is in the differential form. We have to integrate it, right? Yes. Now we have to integrate this equation. Since this minus K is a constant value, we have to only integrate the dt, and the equation becomes integral D concentration of R divided by concentration of R is equal to minus K integral dt, and integration of D into concentration of R divided by concentration of R is equal to ln concentration of R, and that will be equal to minus K. Integral dt is T and plus C, that is the integral constant, and the equation becomes ln concentration of R is equal to minus Kt plus C. We have to know the value for this constant. For that, we are taking T is equal to 0 and the R will become R naught, that is the initial concentration. At T time is equal to 0, the concentration of R becomes concentration of R naught. Placing these terms in this equation becomes ln concentration of R naught will be equal to minus K into 0 plus C. It is almost similar to the zero order chemical reactions, right? Yes. Now, the ln concentration of R naught will be equal to C because K minus K into 0 is 0. So, the value for the C is ln concentration of R naught. Now, place this equation in this equation. So, the equation will become ln concentration of R is equal to minus Kt plus ln R naught. This is in the form of a straight lines equation, right? Y is equal to mx plus C is the equation for the straight line. We can plot a graph where Y is the ln concentration of R. On Y axis we are taking ln concentration of R, and on the x axis we are taking time t, and m is the slope, that is minus K. Slope is minus K. Since it's a negative value, we can draw the straight line downwards. And C is the y-intercept, and ln concentration of R naught will be the y-intercept. Ln concentration of R naught will be the y-intercept. Now we can continue this equation, that is ln concentration of R divided by ln concentration of R naught will be equal to minus Kt. We should know the value for the rate constant. So the K will be equal to 1 by T into ln concentration of R naught divided by concentration of R. Now taking the log of this equation by multiplying it with a 2.303, K will be equal to 2.303 divided by T. Instead of ln, it's log concentration of R naught divided by concentration of R. We can also rewrite this equation as log concentration of R naught divided by concentration of R, and that will be equal to Kt divided by 2.303. And this equation is called the integrated rate equation for the first order chemical reaction. For the first order chemical reaction, the integrated rate equation is this equation. K is equal to 2.303 divided by T log concentration of R naught divided by concentration of R. By using this equation, we can again plot a graph by taking log concentration of R naught divided by log concentration of R on the y-axis and time on the x-axis, and the slope will be K divided by 2.3. Since it's a positive value, we can draw the straight line upwards, and the slope will be equal to K divided by 2.303. The next topic will be the half-life of a chemical reaction, T-half. T-half is the time in which the concentration of reactant is reduced to 1/2 of its initial concentration. It is a time required for a chemical species or the reacting species to reduce to its half of its initial concentration is called the half-life of a reaction. It is different for the zero order and first order chemical reactions. First, learn about the zero order chemical reaction, where time will become T-half and the concentration of R will become 1/2 of its initial concentration, that is 1/2 concentration of R naught. When T is equal to T12, concentration of R becomes 1/2 concentration of R naught. Do you remember the integrated rate equation for the zero order reaction? That was K is equal to concentration of R naught minus concentration of R divided by T. And also we can write it as T is equal to concentration of R naught minus concentration of R divided by K. Now placing these values over here, T12 is equal to concentration of R naught minus, instead of concentration of R, we are writing the 1/2 concentration of R naught divided by K, where K is the rate constant. And T12 is equal to the concentration of R naught minus 1/2 concentration of R naught will give you the concentration of R naught. So the equation will become T12 is equal to concentration of R naught divided by K. This will be the half-life of the zero order chemical reaction. You have to remember this equation. This is the T12 of a zero order chemical reaction. Now we have to learn the first order chemical reaction. The integrated rate equation for the first order chemical reaction was K is equal to 2.303 divided by T log concentration of R naught divided by concentration of R. We can also rewrite that as T is equal to 2.303 divided by K log concentration of R naught divided by concentration of R. Now, putting the value for the T and the concentration of R, it will become T12 is equal to 2.303 divided by K log concentration of R naught divided by 1/2 concentration of R2. And concentration of R naught divided by 1/2 concentration of R naught will give you the value 2. So the equation will become T 1/2 is equal to 2.303 divided by K log 2. Now calculating the log 2 and multiplying it with the 2.303 will give you the value T12 is equal to 0.693 divided by K. So this will be the T12 of first order chemical reaction. This is the T12 of a first order chemical reaction. Hope you understood all the concepts of the integrated rate equation, and in the next video we are going to learn about the collision theory. Until then, take care and bye bye.